more implicit, right, differentiation with taking the derivative with respect to t, and you know that because of the dt's. So I'm going to first rewrite this as just 1/5 times x, so you're not tempted to do quotient rule or anything. So derivative of cosine is negative sine, and then times d theta over dt, carry the 1/5, the derivative of x is dx over dt. Now I'm going to plug the information in, so I know that that's 6, and then oh no, there's no place to plug in x equals 3 over here, is there? Oh, but lots of times, don't I plug the x equals 3 into the original equation? Okay, so if I do that, I get this. I get well, here, that right here, right? I get this. When I plug in those two pieces, I plug in the when information into the original equation. That still might not ring a bell how to do that, but you see the triangle. Yes, you do, because you can see that cosine is adjacent over hypotenuse, and you know Pythagorean theorem, and you know that this side will be 4. Now can you find sine of theta? Yes. From the triangle, you see that sine of theta is opposite over hypotenuse. So I can replace sine of theta with the 4/5, carry that negative along, and then finally d theta over dt is this. Whew. Okay, let's do that again. So if I take the derivative, I get a cosine of theta times d theta over dt. And you see that this is just the number 1/2 times x. So 1/2 times dx over dt. Okay, so let's see what I've got to plug in. Plugging in x equal 1. I don't know where that's going to go. d theta over dt is 4. So I'm just going to carry this along and this along. Okay, so there's not much to plug in, right? So I'm going to use my when information and plug it into here, right? So I'm going to say sine of theta is 1 over 2. Okay, so 1 over 2, so that means that's opposite over hypotenuse. So to find this side, it's the square root of 2 squared minus 1 squared. So this side is root 3. So now I can find, this is the angle, right? I can find cosine of the angle, which is root 3 over 2. And then that carries along, and then I'll just multiply. I'll just take liberties and multiply by that 2 right now. So I end up getting that dx over dt is 4 root 3. Okay, so let's look at this one. So here's the tangent is 1 over x. So first, I'm always going to rewrite this as x to the -1, so easier to take the derivative of. So then I take the derivative of tangent, secant squared, times d theta over dt. Take the derivative, negative x to the -2 times dx over dt. And I will recommend you write the negative exponents in the denominator. So let's see, what did I plug in? So I got d theta over dt is 3, so that's what this came from. And then I'm going to use the theta is pi over 4 to, I can just plug in. How did I think about that? Plug in to get x's. Oh, I needed to find the x. But also, remember, you're going to be plugging pi over 4 in, right? And this is something you're going to want to know. So secant squared of pi over 4. That's like saying 1 over cosine of pi over 4 all squared. That's 1 over the root 2 over 2. Whoops, root 2 over 2 all squared. So that's like saying 4 over 2, that's 2. So it's useful to have memorized this is 2 because you're going to see it so often. So this, I replace it with a 2. Now I'm thinking, how am I going to find out what x is? So this is where you take your when information, right? Your when information and put it into your original equation. We're doing this a lot, right? So if I put pi over 4 in there, tangent of pi over 4 is 1, right? 1 equal 1 over x. Well, there it is. X is 1. So then you can just plug in x is 1. I wanted to show you this problem. You could choose to do it another way. Because I'm not a big fan of these negative exponents, what I could do is before I take the derivative is that I take the reciprocal of both sides. So 1 over tangent, you know, is cotangent. And 1 over x, isn't that just x? Oh, all right. So let's go take the derivative of cotangent. So that's negative cosecant squared of the angle. d theta over dt is dx over dt. Okay, so let's see what we've got. We're going to plug in, different color. I'm going to plug in d theta over dt is 3, right? Oh, and look at that. I'm going to be plugging in pi over 4 into here, right? So negative cosecant squared of pi over 4. And then that's going to help me to find dx over dt. That was a lot less work, right? It is. It's a lot less work. I don't have to go through and find this extra thing. So let's think about what this will give us. So cosecant squared of pi over 4 is really, really similar to what I just did, right? So sine of pi over 4 squared, that's going to be 1 over root 2 over 2 squared. So it's going to be a 4 over 2. It's a 2. So I get a negative 2 times a 3 is dx over dt, so negative 6. So you can choose to do it either way. I'm just going to suggest that this way is a little simpler.